All right, we are going to take a look at composition of functions. Now we have our four basic operations: add, subtract, multiply, and divide functions. This is our newest one, the composition formula. And the way we'll see it is a little small open circle. Okay? So when I see that small open circle, that's referring to a composition. What you're used to seeing is like a dot or side by side, and that means multiplication. So a little bit different here. So we're looking for that open circle. We read this first one composed of the second one. So I would read this as f composed of g of x, d composed of m of x. Now the basic thing that you could do with a composition of functions is rewrite it. So whatever comes second goes on the inside. Whatever comes second goes on the inside. And if you rewrite it, it ends up more of a function notation. So here's what you have done before. Let's say I have f of x equals, let's make something up here, 2x plus 3. Well, that means that f of 2 would be 2 times 2 plus 3, or 7. So we've put numbers in. Right? You've actually done a composition of a function before because you've put a letter in. So if I said f of p, 2p plus 3. So in other words, we just composed this function with the variable p. That's kind of what we're doing. So the general idea was, what we saw in the past was whatever was in here is substituting in for x. Okay? So if we can rewrite our composition into this function notation, then we're back doing kind of what we did before. So let's take a look at it here. We get a couple functions here. Let's say f of x equals 2x plus 3, and we'll say g of x equals x squared minus, I'll just make it a little bit larger, x squared minus 2x, something like that. Okay. So when I'm asked for a composition, if I was asked for f composed of g, so again, I read that f composed of g, this means g is on the inside, whatever second's on the inside. So rewrite it, f of g of x, where you're seeing g sitting on the inside. If you rewrite it in this format, then what you're doing is you're actually substituting the g value in for g. So it looks like this. So I've got g of x inside. This was g of x going inside. And now this is f of this. So remember, whatever's in here is going in for x. So we would have 2 times x squared minus 2x plus 3. There's my composed function, what I've got there. So that being said, I know I can distribute the 2 and things like that, but I'm just trying to write that raw function format. Well, let's say we had f composed of f. So this just means I'm going to take f and put it back into f. So here's my rewrite. I think it's always helpful to do the rewrite first. So we'll have f of x. So now f of x is on the inside. So I'm going to replace this with that 2x plus 3. And now this is saying we're going to substitute 2x plus 3 in for x in the f function. So I would have 2 times 2x plus 3 plus 3. Again, just trying to write the raw form, get some practice here. Of course, you can go through and distribute the 2 and combine like terms, just working with that raw form. Let's go the other way. Let's go g composed of f of x. G composed of f of x. So now f is on the inside. F is sitting on the inside. Right? Since it came second, g composed of f, f sitting inside. So now I'm going to put that f value in there which is 2x plus 3. And now 2x plus 3, substituting for x in the g function. So I would have 2x plus 3 squared, goes in for x here, minus 2 times, there's my x value again, 2x plus 3. There's my composite function I'm looking for. Now let's look at something with, do some like numerical, kind of see what's going on here. So I'm going to switch and give us like 3 functions here. Move this back a little bit. Let's go with f of x, x squared minus 1, g of x, 3x, and let's go with h of x, negative 2x plus 3. Just make up 3 functions there. All right, so I've got f, g, and h. Okay. So let's find f composed of h of 2. So we'll just use numerical. Whether it's numerical or variable, I would still suggest just doing the rewrite. Right? So we're going to rewrite with h on the inside. So we read this as f composed of h of 2. So this is what my rewrite looks like. I put h of 2 inside of f. So this is the first piece I'm evaluating right here, h of 2. That means we're putting 2 into the h function. So h of 2, that would be negative 4 plus 3 is negative 1. And now we're evaluating f of negative 1. So f of negative 1, negative 1 substituted in for x. Negative 1 squared minus 1 would be 0 because we'd have 1 minus 1. Okay. The key still, if you can see it and visualize it really well, then great. If you're struggling at least a little bit, then do the rewrite. This is what's going to help you. So let's go h composed of g of 3. Okay. So again, the first thought is which one's on the inside, and in this case the g is on the inside, so I'm going to rewrite it. H of g of 3. Now I'm working inside out, so I'm going to find g of 3. G of 3 would be 9. 3 times 3 is 9. And now I'm going to find h of 9. So 9 going in for x. Negative 2 times 9 plus 3. Negative 15. We're going to rewrite it, then work inside out. Rewrite, work inside out. Let's go g composed of f of 4. So now f's on the inside. So we're going to have g of f of 4. G of f of 4. Now we're going to find f of 4. So that would be g of, so f of 4, 16 minus 1 is 15. And so now we're finding g of 15, which would be 3 times 15, which would be 45. Okay. So again, key is that rewrite, that piece. All right, I'm going to go back and let's do one more with a number, and then I'll go back to the variable pieces. So let's go h composed of f of, we'll go 2. So f's on the inside. H of f of 2. So we're going to find that f of 2 first. F of 2 is 4 minus 1 is 3. So now we're finding h of 3. 3 going into my h function, negative 2 times 3 plus 3, that would give me that negative 3 value piece there. Okay. All right, we'll go back to function 1. Look at another example here with just variables. Okay. Let's say f of x is, we're going to say 3 over x minus 2. And let's go with g of x being, let's just say 2 over x. All right, so just get a different look here. We're still going to find the composite functions, but we didn't see fractions before. So let's take a look here with the fractions. I want to find f composed of g. F composed of g, so this means g on the inside. So I'm going to rewrite it with g on the inside. All right, so still I substituted that g value, 2 over x. And now this means that 2 over x is going in for x in the f function. So it'll look like this, 3 over 2 over x minus 2. And you know, looks kind of rough as far as the setup, getting a complex fraction, but we still took whatever was in here, substituted for x. Now let's look at the simplifying here. When you simplify, you can multiply everything by x to clear out the fractions. That's what you did in the past. Make 2 minus 2x there, something like that. So that would be my simplified function. Now, when we're working with fractions, we run into these different domain restrictions. Okay, so when I look at this, the domain would be x cannot equal 1 or 0. Okay, now remember on a fraction, domain would be you can't divide by 0. So we're looking right here. Hey, what makes a 0 down here? Well, a 1 will, because 2 minus 2 is 0. So if x was 1, then that would blow up the whole problem, so x can't be 1. So the question comes in, well, where did the 0 come from? And this is what's happening on the fractions. First off, your original functions had domain restrictions. So this one would be x can't equal 2, and this one would be x can't be 0. Well, when I substituted g into this, doing my composition, it has a domain restriction of 0. So it's kind of like it has a genetic defect already, it's just carrying through. So this defect is carrying through, still right here, notice you can't divide by 0. Now when you simplify it out, now it can't be 1, but you can go back here, like 2 over 1's 2, minus 2 is still 0. So it's producing both. So this one's the one out of the simplified, and the 0 is coming out of that inherent piece. Now let's go the other way. Let's go g composed of f of x. So I'm going to rewrite g of f of x. So now f's on the inside. So that would be 3 over x minus 2. Now, as far as the domain piece I was talking about before, this has a domain restriction of x can't be 2. So I don't know what's going to happen at the end of the problem, but I know x can't be 2. I know it's going to carry that along. So let's keep going. We're going to put this in for x in the g function, 2 over 3 over x minus 2. Now if I simplify this, I would multiply top and bottom by x minus 2. So there's my function. Or I can rewrite it 2x minus 4 all over 3. And now I'll state my domain. Domain, x can equal. Well, there's no problems right here. There's nothing wrong with a 3. I don't have any domain restrictions whatsoever here. But I do have the inherent piece of x can't be 2. So that's still part of the domain. I knew it was going to carry through to start with. I didn't know if I'd end up with something else. So just to review, I knew it couldn't be 0 to start. It's going to carry through, and we ended up with another restriction on that back end. This one we did not. So a composition just means I'm going to take one function, put it inside the other, we've worked with function values. Now we're just actually taking, instead of a number, we're putting an expression in for x. So this is that raw form we simplified. Now we didn't talk much about domain on the first ones, but that's because if you look back at the notes or the first part of the video, the domain was all real numbers for any of them. So when you take an all real number and compose it of an all real number, the domain's still going to be all real numbers. And you can look at any of the final functions, they would still be all real numbers. So that part's not going to matter. But when you do have domain restrictions to start with, you know you're going to have a domain restriction at the end, and you may have another one sitting there in that case.